Welcome to Study Loop.
Hello students, in this question it is given as the kinetic energy of proton is given as 4.70 mega electron volt. When it is converted into joules, it is equal to 7.530 into 10 power minus 13 joule, and the magnetic field is 0.0450 Tesla, and its initial position is equal to 0 meter, whereas its final position is equal to 1 meter. So first we have to calculate the y component of the moment of the proton. For this we have to calculate first the general momentum of the proton. So momentum of proton is equal to 2 into m into k. K is the kinetic energy, so we can put Ke like this. So into mass of the proton is 1.67. Let us not confuse with this. Into 10 power minus 27 kg into 7.530 into 10 power minus 13 joule. So when it is calculated, we get that the moment of proton is equal to 5.015 into 10 power minus 20 kilogram meter per second. Now we can calculate the y component of the moment of the proton. Therefore, the y component moment of proton can be obtained as Py is equal to P into sine alpha. Therefore, P is 5.015 into 10 power minus 20 into sine of this. Sine theta has to be find out. So let us keep it as such. We will continue the other calculation. So finally we will come to this point where we can put theta. So first, from the previous calculation, from the moment of the proton, we can calculate the radius of the path of the proton. Radius of the path of proton, that is R is equal to P divided by Q into B. So P is equal to proton momentum is equal to 5.015 into 10 power minus 20 kilogram meter per second divided by charge is 1.6 into 10 power minus 19 into 0.0450 Tesla. So on calculating this, we will be getting R is equal to 6.96 meter. Then the displacement of the proton has to be calculated. The displacement of the proton is equal to del x is equal to x final minus x initial. Therefore 1 minus 0, which is equal to 1 meter. Then we have to calculate the angle between the proton. That is the angle between the incident proton and the emergent proton. Therefore, it can be given as incident proton beam and the emergent beam, proton beam. Therefore, sine alpha is equal to del x divided by R. Therefore, 1 meter divided by 6.96 meter. This is 96 meter. Therefore, on calculating this, we are getting 0.162. Therefore, sine alpha is equal to 0.162. Therefore, alpha is equal to sine inverse of 0.162, which is equal to 9.32 degree. So this is called theta. This we have to substitute there in the y component. So here we have to put 9.32 degree. So on putting this, we will be getting the y component of the momentum of proton as Py is equal to 8.122 into 10 power minus 21 kilogram meter per second. So hope you find this video useful. Thank you.